This video is all about meter accuracy and display counts and how they interact with each other to affect the meter's total accuracy. It will explain things like why this meter that is accurate to within 1% at 20 volts on one scale can be off as much as 30% on another scale. Most meter companies like to put out selection guides to help you choose their meters, and they might list something like the basic DC accuracy. Other meter companies might list accuracies for several of the functions on the meters, like shown here. The problem is this doesn't come close to telling the whole story. Meter accuracy is actually made up of 4 components that all work together to give your meter the total accuracy of the reading. These 4 components are the percentage of the reading, which is actually the basic accuracy you see on the chart, the digit accuracy of the reading on the display counts of the meter, and the resolution of the meter. So forget about the basic accuracy alone and take a look at the user manual. In the manual you will see that basic accuracy percentage with a number behind it. That number is the number of counts you need to add to the percentage of accuracy. This is also sometimes called the least significant digit in the display. These counts can have a big effect on the accuracy of your meter. Here I have 2 meters that both have a basic AC accuracy of 1%, but the fluke on the right has an accuracy of 1% plus 3 digits, and the south wire on the left has an accuracy of 1% plus 30 digits. Let's take a look at how these 2 numbers combine to affect your total accuracy. The fluke on the right has an accuracy of 1% plus 3 digits. Since our current reading is 24 volts, 1% of 24 volts equals 0.24 volts. 3 digits, since we have 2 decimal places of resolution right now, would equal 0.03 volts. This combines to equal plus or minus 0.27 volts of accuracy, which would also equal about 1.12%, which is real close to the 1% basic AC accuracy of this meter. The south wire meter has an accuracy of 1% plus 30 digits. So for our 24 volt reading, 1% is the same, 0.24 volts. But 30 digits, since we have 2 decimal places of resolution, equals 0.30 volts, which would give us a total accuracy of plus or minus 0.54 volts, or 2.25%. So the 30 counts really affected the accuracy. Instead of being close to 1%, we are now over 2%. At 120 volts, 1% of 120 volts would equal 1.2 volts of accuracy, and our 3 counts, now since we only have 1 decimal place of resolution, would equal 0.3 volts. This would combine to give us plus or minus 1.5 volts of accuracy, which equals 1.25%. Still pretty close to our basic 1% AC accuracy. On the south wire meter, our 1% of accuracy equals the same 1.2 volts. But now that we only have 1 decimal place of resolution, 30 counts is going to equal 3 volts of accuracy. This will combine to give us plus or minus 4.2 volts of accuracy, which equals 3.5% total accuracy. You can see that the south wire meter is currently reading 118.8 volts, which is 1.2 volts off of the 120 volt reading. If you were looking at just the basic accuracy of 1%, you'd think this meter was at the limits of its accuracy. But this meter can actually be off by as much as 4.2 volts, so it is still well within its specified accuracy. As you can see, that 1% basic accuracy does not tell the whole story, and you really need to look inside the owner's manual, look at how many counts are associated with that accuracy to determine how accurate your meter is going to be when reading different voltages. Next on our list of items that affect accuracy is display counts. For a detailed explanation of what display counts are, there is a link to a video that explains this in the description of this video. Simply put, display counts will determine at what voltage the meter will switch ranges, and this will have an effect on the number of decimal places shown for that voltage. Here I have a Klein meter that is 4,000 count and a fluke meter that is 6,000 count. The Klein meter has an accuracy of 0.75% plus 5 digits, and the fluke has an accuracy of 1% plus 3 digits. So at 12 volts, where both meters have 2 decimal places of resolution, the Klein has a total accuracy of plus or minus 0.14 volts, and the fluke has a total accuracy of plus or minus 0.15 volts. At 24 volts, both meters still have 2 decimal places of resolution. The Klein has an accuracy of plus or minus 0.23 volts, and the Fluke has a total accuracy of plus or minus 0.27 volts. So the Klein meter has a higher accuracy for these voltages. But at 48 volts, the Klein now only has a single decimal point of resolution, and the Fluke has 2 decimal places. So at 48 volts, the total accuracy of the Klein is plus or minus 0.86 volts, and the Fluke has a total accuracy of plus or minus 0.51 volts. So at 48 volts, the Fluke has a higher accuracy than the Klein. Even though the Klein has a better basic accuracy of 0.75% versus the Fluke at 1%, the display counts allow the Fluke to be more accurate at certain voltages. This brings us to the final item on our list, which is the resolution of the meter. Here I have 3 meters showing 120 volts. They're all within 1 volt of each other and all within their published accuracy. Right now, they all have 1 decimal place of resolution. If I take my voltage down to, let's say, about 1 volt, so I'm at 0.9 volts here, I see 0.9 on the Fluke. It has 3 decimal places of resolution because it automatically ranged. This is at 0.7 volts, this is at 0.5 volts. Now this meter has more settings as a manual ranging meter, and I can put him in the 2 volt scale, and when I put him in the 2 volt scale, I'll be able to see my same 0.9 volt reading here. But this meter only has 1 setting for low voltages, and everything under 200 volts is on this setting with 1 decimal place of resolution. So at higher voltages, he matches these other meters very closely. At low voltages, instead of showing 0.9 volts, I'm showing 0.5, almost 50% off of the reading, and he's still within spec. So when looking at meters that you might be measuring some lower voltages, make sure you can get into an auto-ranging meter that can give you high decimal places of resolution, or a manual ranging meter that gives you more settings so you can get that higher resolution. Locking yourself into 1 decimal place of resolution is going to make for very inaccurate readings at low voltages. So resolution accuracy is the reason why meters like this can read 20 volts very accurately with 2 decimal places of resolution, but can be off greater than 30% when switched to a range that has 0 decimal places of resolution. Hopefully this video has shown you that a meter accuracy is much more than just the basic DC accuracy that is listed on many spec sheets, and that these 4 items all work together to determine your meter's total accuracy. There's a lot more to learn about selecting the right meter or how to use your current meter more effectively. Make sure you subscribe to this channel to learn more about meters and to see reviews.